When you're multiplying two fractions like this, we have two different ways of doing it. One way would be to multiply across the top, across the bottom, and then reduce that way, or we can cross cancel as we multiply. Now in this problem here, if we do 4 times 24, we'll get a little bit larger number, and we may not know exactly how it reduces with the 6. So in this problem, what we can do is we can reduce as we go along here. So for this problem, first thing we notice is that the 6 would divide into 24. So 6 divided by 6 is 1, and 24 divided by 6 would be a 4. So if we multiply this next, we're going to have a 16x squared over just 1x squared or x squared on the bottom. Now, something else that we notice here is that the x squares, top and bottom, both of those are going to cancel. So I can cancel both of those out, which means that I get 16, and that's going to be my answer. Everything else got canceled. So that's one approach for doing these kind of problems, is to cross-reduce as you're multiplying. But sometimes the numbers are small enough to where we could just multiply across the top and across the bottom and just reduce one time at the end. And that's what I'm going to do on this next problem here. On this next one, if we multiply that, we can do 2 times 50 is going to be 100. So 100 we have times x plus y. And on the bottom, if we multiply that, it's going to be 50 x plus y squared. So for this, we can divide 100 divided by 50. 50 divided by itself is 1. 100 divided by 50 is 2. Now, at the same time, we can also reduce these powers here, x plus y. That would be x plus y to the first power. So I have one of them on top, and I have two of them on the bottom. Well, what's going to happen is I can get rid of the one on top, and that will get rid of one of them from the bottom. So this goes away completely, and this is going to turn into a power of 1. So what we have left over is we just have a 2 on top only. Everything else got canceled out. And on the bottom, there's a 1 there, but I have an x plus y that's still left there. So I have 2 over x plus y, and that's going to be my answer fully reduced. We can use that same strategy on this next problem. Okay, so once again, I'm going to multiply this across the top, across the bottom. When I do that on the top, I have 2x times x plus 7 squared. On the bottom, when I put that together, it'll just be 10x squared and then x plus 7. So I don't want to multiply this through or and distribute that. I want to keep it in this factored form because that way I can cancel things. That's the whole idea for this. So you usually want to keep things in a factored form. All right, so first let's start with the numbers. 2 over 10, that does reduce. So 2 divided by 2 is 1. 10 divided by 2 would be a 5. So I have a 1 and a 5 there. Now the x's I can also cancel. I have one of them on top, and I have 2 of them on the bottom. So I get rid of the 1 on top. That means this is going to turn into a power of 1. And then I can do the same thing with these. X plus 7, I have 2 of them on top and 1 on the bottom. So 1 on the bottom goes away, and that's going to turn into a power of 1. So let's rewrite what we have. So far on top, I just have a 1, and I have x plus 7 to the first power. So that's just going to be x plus 7. On the bottom, I have 5, but then everything else here, I have a 5, and I have an x to the first power. So that's all I have left. The x plus 7, that canceled out, and the 10 is gone. So I just have a 5x only. And that's as much as I can do as far as reducing. So I'll leave my answer as that. So let's try one more of these kind of problems. All right, now this one, I have 2 times 98, and then I have 7 and 14 on the bottom. So I'm going to multiply across the top, across the bottom in this case. All right, so when I multiply this, I'm going to get 196, and that's going to be c plus d squared. When I multiply 7 times 14, get 98, c plus d cubed. Now this, the 196 divided by 98, that does go in evenly. So you can always check that with a calculator to see if that goes in evenly. In this case, it does. So 196 divided by 98 would be actually be a 2. So 98 divided by itself is 1. 196 divided by 98 is a 2. But I can also reduce the C plus D as well. There's 3 of them down here and there's 2 up here. So the ones on top will get rid of 2 of them down below. So if I get rid of these, that's going to change to C plus D to the first power. Let's rewrite what we have. I have a 2, and that's all I have left on top because everything else got canceled. On the bottom, I have a 1, and then I have C plus D to the first power, and that would be it. That would be fully reduced.